Hola, nuevamente bienvenidos a la JConf Perú 2022. Estamos aquí nuevamente iniciando una nueva charla. Comentarles que no se olviden de postear sus preguntas y registrarse en el Meetup. Al final del evento habrán 2 licencias de IntelliJ que van a ser sorteadas y también no se olviden al cierre porque van a haber algunos announcements para que, sobre todo para la conferencia del próximo año. Es que vamos a hablar sobre nuestro speaker, Bazlur Rahman. Él es ingeniero de software, Java Champion, autor, blogger, también speaker o conferencista. Tiene más de 10 años de experiencia en la industria del software, principalmente en Java y tecnologías relacionadas a Java. Le gusta mucho el mentoring, escribe bastante, hace conferencias, contribuye a muchos proyectos open source, es el fundador y moderador de Bangladesh Java User Group desde el 2013, organiza distintos meetups, conferencias sobre tecnologías relacionadas a Java con la comunidad, es editor de JavaQ at InfoQ, el líder es también, ¿cómo se llama? Organizador de conferencias, also es entusiasta del OpenJDK. And, well, él se va a unir con nuestra charla, que es Creating a Million Virtual Threads Using Project Loom to Improve Throughput. So, Bazlur, welcome, and I give you the screen.
Thank you very much. I'm sure you have given me a wonderful introduction. Thank you for that. So I'll begin with sharing my screen and let's see if you can, see it properly. Let me know if you can't. Okay, so let me move that screen from here. Okay, so is this screen is okay? I mean,
Yes.
I guess. Okay, perfect.
Yes, it's okay,
So
Bazlur.
all right. So I'll show the ID as well. Let me know if I need to improve the font size because I have a couple of demo as well. Um, you know, is
Yeah, I
this
can see the
font
fonts. Yeah, I
or
can see
should
the code correctly, and go. Let's go.
okay, perfect. All right, so let's begin. All right, so as you already know, the title of this session is creating millions threads using Project Loom, which is the new things that Java 19 brought. All right, I'm gonna skip this slide because I've been introduced already. So let me skip that. Moving on. So here's the agenda. Basically, what I'm going to speak about today. Pretty much, I'm going to give you some context of Java concurrency, what it is actually, and then on top of that, since the talk is essentially on top of virtual thread, so I'll go into that and how it makes sense and why do we care about it and if there are any limitations. So these are the basically high level agenda of this whole talk. And since the virtual thread is still not part of the JDK yet, I mean it's there with under preview feature, so we are not be able to use in production yet. If we want to, we can use, but it's still under under heavily development. So this is going to be high level because we don't have the final thing yet, right? So yeah, so that's I wanted to clear up front. So moving on. So here's a few things. Just give me a second. Just give me a second. I'm trying to fix my. Um, okay, so essentially, okay, that's my first slide basically. All right, so you know in Java, threads are way of expressing concurrency, right? So from the day zero, Java introduced threads. Java was developed on top of the concept of threads basically. Threads are, we can say, threads are basic unit of execution in Java. So what it says is whatever code we want to execute in Java is executed by a thread, and threads are sort of independent unit of execution on a Java platform. What do you mean by that? Let me give you an example. Okay, so you can see there's a main method over here, And if I run a code over here, I mean, from this curly brace to this curly brace, whatever code I write over here is going to be executed by a thread. That's the fundamental things. So how can I prove this? I can write a system out print line, and I can print something like that, the current thread. So if I write thread dot current thread, and if I run it, I'll see uh, the name of the thread it's executing. That's a one way of proving this code is running under a thread. So yeah, so as you can see, current thread is basically main. So main method is always executed by a thread called main thread. And then from this main thread we can create sort of other threads, right? So that's what it is in Java. And so from this, what we can understand is, if it has more place where we can run code, that's better, right? That means we can do more things simultaneously. That brings a lot of benefit on the table. One particular benefit is that it could improve application throughput by utilizing all the resources we have in this machine. For example, like in this slide you can see more threads essentially means more execution environment, right? So, and when in applications like in our modern, all of the applications is very responsive. We click on a button, immediately we get something else in happening on this screen, and it also do certain things on the background, a lot of things happening at the simultaneously. That's sort of achieved by thread in Java programming language. All right, moving on. And that's the first statement I made. Java is made of thread. Second is threads are all layer of the Java platform, be it exceptions, thread locals, debugger, profile. There is a one thing we know that threads just not only executes code, it also keep track of the invocation of methods in its stack, right? When we create a new thread, it gets a 2 MB of stacks. So from where we store a lot of things. So we get an accept. Let's say it's executing something, and then we got an exceptions. And when it runs into a trouble, while executing a code, for example, an exceptions happen. Maybe it could be arithmetic expression or something else. Doesn't matter. We get a stack test, right? And from this stack test, we can read all these informations, how we and where we got a problem. So thread is in a way, exceptions are made available through the threads. And there are other use cases. For example, if we need to debug a program through an IDE, we use thread. If we need to profile a program or a particular part of it, we need thread. And as you know, Java use garbage collection. It's also run in a separate thread. All of these are basically point out that concurrency in Java or threads are integral part of programming platform. Java platform, right? So bear in all this mind, because what I'm trying to do is I'm trying to give you a background of concurrency, and then on top of that we'll build the other stuff. Moving on. So how do we create threads? It's simple. The basics creating thread is basically, you can instantiate the instance of thread, and then you can start and then wait for it. I can quickly show you a demo over here. For example, var t1 new thread, and you can pass anonymous inner class, but lambda expression is the way to go nowadays. So we always use lambda expressions. So whatever let me just copy this line over here, and I'll give a name of this thread, say jconf arrow, right? So I have given a new name for this particular thread, and then I'm gonna start. I'll wait so that the idea is okay. So let me explain why I need to use join over here. So basically, from this curly brace to this curly brace, main thread start executing, right? So it will execute this code. It will execute this code, which is basically creating an instance of new thread. Then it will execute this line, and it will start the thread. if I don't use join, it has nothing to do nothing to execute anymore, right? So it will finish and it will die out. uh, if this T1 start a bit late, then we'll not see the see the result over here. So what I'm essentially saying is, until T1 finishes its job, please wait, so that we can see both results. All right, so let me start this program and see. As you can see, now we have two threads over here. First line was executed by main thread, which is line number 5, and then the line number 8 was executed by our new brand new thread, which is jconfero. So that's how we create, essentially threads. It's an easy way. There are other advanced way of creating threads, but for this demonstration, this is enough, I think. All right, moving on. So the one thing we have to keep in mind in Java is threads are not usually is a Java construct. What do I mean by that? But it means, operating system basically gives us thread, and in Java we have a thin layer. So Java doesn't control threads. Operating system does, basically. So when we create threads, we basically ask operating system to give us a thread, and the thread class is basically a wrapper around it. So we have to keep that in mind as well. All right. So here's the other things we have to keep in mind, which is threads are costly things, because it takes, like, if we create a new threads, it takes around 2 MB of memory outside of the heap. That's the usual in Linux operating system. I'm not exactly sure what other operating systems use, but this is for Linux environment. It takes around 2 MB of memory. Anyway, so like I said, it's a wraparound of OS threads, and context switching also takes some time. All right. So which entails, if we do the calculation, that means if you want to create 1 million of thread, that means it requires 2 TB of memory, right? That's a huge memory. And then, let's say in my computer I have a 10 CPU there, and I have created 1 million, and all of them will going to context switch simultaneously, and the operating system will be especially the thread scheduler will be very busy, so it will drop the performance as well. So that's not a feasible things as well. Now, uh, uh, that's the what I have just said. It's here. Moving on. So so let me go back to this slide again. So over here we conclude that if we want to create 2 million threads, it will require a huge resource. That's now the question is, can we create this much of thread theoretically, or practically? Maybe theoretically it's possible. Practically it's probably not, because because of this, because threads are basically limited. We have an example over here. With this program, you can do an experiment on your computer and see how many threads you can create before it crashes. So I did this experiment on my computer, and I was able to create sorry I was able to create 16,000 threads, and then my Java JVM crashed because of out of memory, and I have this configuration of my computer. So as you can see, it's not even feasible to create as many as threads we want to create, let alone millions. All right. So why we need millions of threads? That's an important question you may ask. The answer is, modern Java web applications throughput is achieved by concurrent connection. What do we mean by that? I mean by that is, when we send a request to a web server, it gives the threads to work on that request. So a request comes, a thread takes the request and do all these things and return the response to the client. So that means if I send 1,000 requests, I'll have theoretically I'll have 1,000 threads to work on those things. And if I send another request, let's say in my computer I have only available 1,000 threads, so I can simultaneously request 1,000 uh, you know send 1,000 requests to this server. But if I want to send more requests, it will it has to be, it will wait, because all the threads are busy currently serving other thousands requests. So we are sort of limited by this, by the number of threads available. So that means even though we want to higher throughputs, we are not able to achieve that because of these limitations. Although modern OS can handle millions of concurrent connection, I mean, it can open millions of sockets. That means it is possible, theoretically possible, to a higher throughput, but we cannot do this because we have a limitation of threads. That's a problem we are trying to solve, basically, at least in this context. Let me give you a practical example. Basically, this is what it happens in our modern application, web server applications. So let's say we have a web server, and then a request come, and it will be handled by a thread, so thread 0, and it will go in database or something else. It doesn't matter, whatever it wants to do, it will do. And then another request will come, it will be given another threads. The problem is over here is that like, threads are limited, and we don't want to waste them. That's the idea we have to keep in mind. But in this scenario, we usually end up wasting our resources. How, you may ask? Let's say I have sent a request, and I was given a thread to work on that request, and while I'm working on, the web server is working on that request, it needs to connect to the database, or it needs to connect to the web server, right? So while it's waiting on that result to come to this thread, it's just waiting, it's blocked until it gets the result. So maybe the round trip from this thread to the database server is, let's say, 200 millisecond. Until it gets the result, this 200 millisecond, this time, the thread is basically waiting to get this result, and it's blocked, and it's not doing anything. So since we have a limited number of resources available, and we cannot have as much as we want, but ideally we ended up wasting these resources. That's a problem, that's definitely a problem. What if while the thread 0 is waiting for this result, it can do something else? Then we could improve, it could serve other requests, and when the result is come, it will then quickly switch back to the other threads and return back to the request. We can utilize that threads and resources. That will definitely improve our applications throughputs, and also other things in terms of performance. So that's what basically we want to achieve, but that's our current problem we have. Anyway, I just wanted to give you the current situations. Moving on, I want to give you a quick demo over here. So let me see if I have this quick demo over here. Meanwhile, if you have any questions, feel free to ask me. I'll definitely, you don't have to wait until the end. I can answer questions anytime you want. All right. So let me, while I'm find the demo, if you have questions, feel free to ask. Okay. So I'm sure I have a demo over here. Okay. So if I don't have, I can just explain this code over here. So over here, what I did is I've created a server sockets, 8080, and while true, it just accept a request from the client and then handle it. It's a basic, extreme high level of web server applications what we have nowadays. All right. So we can improve. It's a single single threaded web server. Let me see if I have this single threaded web server. Okay. Okay. So this is a let me remove that quickly. So I don't need to. I need this line. I don't need this line. So I'm just going to call this handle socket. So what we have over here, is basically I have created a server socket. I'm waiting on it, and if there is a client, come to my server, send a request, I'm going to handle it. The problem with this what do we say? This single-threaded server is, let's say I want to create send a request. Okay, so now let's say I want to send a request to the server, so I can do telnet, right? That's a easy way. Okay, so it says it's connected, and you can start typing. Okay, so let's type what it does. If I send hello, it just convert into uppercase letter. That's what it is. It is. It's not a fancy web server. Uh, and I'm just trying to demonstrate the problem what we have with these current web server applications. All right, so now let's say if I want to create another client, let's say telnet, and if I send anything, I don't get any response. And it doesn't even say it's connected, because it's already serving this request. It's already serving another client, because it's a single threaded web server. What if I turn this application into a multi-threaded web server? I can just create a new thread every time when we get a request, right? So that's what essentially earlier it was. So let's say I do something like that: new thread, and then I put this handle method inside over here, and then I call it start. So now if I rerun this whole program, I'll be able to connect multiple clients with this server, because every time I'm sending a request, I'm getting a new threads. The creating with new threads with this approach is basically we're creating a new thread on an ad hoc basis, so we don't have control over it. I mean, how many threads we want to create? So basically, if we get 1,000 requests, it will create 1,000 threads. What if I send 2,000 requests? It will try to create 2,000 threads, but we have a limitations, right? We cannot create as many threads as we want, so we don't have any way to control over here. So that's why what we do is we create a thread pools essentially with the executor frameworks. So we can create we do something like the executors new fixed thread pool. Let's say we want to give 100 threads to this server, and then instead of creating new thread every time, so we just submit work to this thread pool, so that all these threads, even though we have, let's say, 1,000 requests, but I have 100 threads in this server, and 100 threads will work on those first 100 requests, and then once they are served, the next batch will come. So that's the idea basically, with this approach. Handle, so socket, right? So if I run this program, I'll have to able to connect multiple multiple clients. But still, we have a problem with with these limitations, which is we are bounded by a number because of our limitations. All right, moving on. But that's the example over here I have used. Let me go to the next slide. And there is a demo over there is a simple class over here which is called DDOS Adduct. You can try on your own. I'm not going to show this demo because it may end up crashing my computer, and the since I'm presenting, I don't want to interrupt. So yeah, so you can do this experiment. What it does is send bunch of requests to this simple web server applications, and if you do so, you will end up getting the exceptions. Basically, your application server will crash. So that's what we want to prevent essentially. All right, so that's where Project Loom basically comes. And Project Looms, if we remove if we change this new fixed threadful to new request, there is a executor start, there is a new algorithm of new way of creating thread pools, which is new virtual thread per task, which is this new virtual thread per task executors. We will have will not have any of those problems which I was describing so far. What it will do is these executors, whenever we have a new task, new request, it will we will submit the task to this thread pool, and this thread pool will create a new virtual thread, and that's it. It can even create a millions of virtual threads at a time. So that's the demo I wanted to show you. For example, there is a class over here. I took it from the Java Specialist EU. Hence, Heinz Cabos actually, wrote a nice article on it. So I took this example and I wanted to show you a demo. So let me run it. Basically, this is creating a virtual thread over here. You can see start virtual threads, and as you can see, it creates already 12 million of virtual threads. So this entails that we can create millions of virtual threads. I'll show you the difference between what the regular classical or the kind of thread we're used to between the virtual thread in a moment. But just bear in mind that we can now, with this Project Loom, we can have a million virtual threads. So that's the demo just I have showed you, right? Moving on, and then I'll explain. So the thing is, so our operating system can handle millions of socket, millions of connection, and the limitation we had with the number of limited thread, it's no longer exist. That means we can have millions of virtual threads and can handle those each request, which basically means we can have a higher number of throughputs. So that's the idea of this whole talk. That's the I started with an assumption. We had a limitations. These are these limitations, and with this Project Loom, we get away from all these limitations. So this was my first part of this presentation, and now what I'm going to do is how this Project Loom works, from the background. So, all right. So let's move. Let's go into that. Meanwhile, if you have any questions, feel free to ask me. I'm not sure how do I get those questions, but feel free to ask questions I mean, whatever medium you are watching from. It could be Facebook, it could be YouTube. Just ask your questions. Okay. So all right. So Project Loom basically highlights allow us to create millions of cheap, lightweight virtual threads. That's the highlight. So now we had an idea of thread, which is basically a class threads. And now we are calling a different kind of thread, which is called virtual thread. So we can call these two types of threads. I mean, we can divide these divided these two type of threads into two groups. First group is basically platform threads. We can call it carrier threads. Basically, these are real native threads that operating system handle or operating system gives us. We can call them classical threads as well. Doesn't matter. Basically, you don't call them virtual thread. That's only difference. And the other kind of threads is basically virtual thread, or you can call it user threads. That's it. So we have two kind of threads: platform threads, or carrier threads, or native threads, classical threads, and the other kind of threads is virtual threads. All right. Moving on. All right. So let me. So moving on. Now, how we're going to create virtual threads. There is a multiple ways of creating virtual threads. Let me show you that demo quickly. So first one is thread.opVirtual is the factory method. You can create virtual thread using this method, and you can call unstarted this method. That will give you a reference of virtual thread, and then you can call started. So that's one way of creating virtual thread. The other way is you can directly immediately start the virtual thread, which is thread.start virtual thread, and then you can pass a lambda expression or whatever code you want to execute inside using this virtual thread. So that's a two way of creating virtual thread. since we have a nice factory method over here, it makes sense to have similar factory method for regular thread, which is platform or classical, whatever you can call it. It's just new edition of it. It doesn't you can always create a new thread using new thread. The only caveat is you cannot create a virtual thread using the new operator. You can create regular classical or platform threads using new operator, but if you want to create virtual thread, you have this two-way. One is of virtual and another is start virtual thread. And if you want to create if you want to use the executors framework, the one we have been using for like decades, you can just use this executors new this one. So this will definitely not create a pool, but it's a way of replacing. The idea is if we had executors in our code and we are submitting tasks, we can just use the same code base without changing a lot. So that's why new way of new factory method added in this executor. So if you want to submit a new task to this, we can just submit a task over here. This task is going to be executed by a new virtual thread. So that's the idea. So basically, whenever we submit, it will create a new virtual thread and it will execute that code with that virtual thread. That's it. So these are the three ways of creating virtual thread. Moving on. Okay, so I've just showed you the demo. All right. So we have to keep in mind, my slide is a bit old because I was preparing it for JDK 19. JDK 19 is released, so you can still use JDK 19, but it's also available in JDK 20, and moving on, it will be available until it's and you have to use preview, enable preview this flag to be able to compile it and also run it, because it's a preview feature. It's not yet released fully. So you have to keep in mind these flags. You can try, and I'll definitely share these slides with all of you, and all this code that I have. I shared all of these things in GitHub, so you can just copy and or download this whole repo and try out. But keep in mind, you have to use this flag, which is enable preview. Okay, moving on. So now the question gets to be how it works basically. So virtual threads basically, very high level are two things. Which is one thing is called continuation, and the other thing is called scheduler. And scheduler is basically a bunch of carrier threads or in a forkjoin pool. What do we mean by carrier threads? Is basically classical threads or native threads or platform threads, whatever you call it, doesn't really matter. And we know that there is a thing called forkjoin pool introduced in Java 7. So it's a thread pool basically. So we can call virtual thread is a Java construct or a construct or a wrapper or whatever you call it. It's basically called continuation. It's run on top of this existing thread pool, which is forkjoin thread pool. So that's the idea. And what is continuation? That's what I'm gonna discuss next. All right. So continuation is basically, by definition, is a sequential of code that may suspend itself and can be resumed later. That's the idea. When it suspend, control is passed outside of the continuation, and when it resumed, control return to the last yielding point. So let me, before going into this, let me just show you a demo if I can. That will be more helpful, I think. So here's the idea. So you have to keep in mind that continuation is a internal part of the JVM. So we are not supposed to use it directly. We are going to use virtual thread, and virtual thread is made of continuation, and continuation is internal class. We cannot just directly use them. So just to show you demo, I have just import this internal VM, and I had to use this flag to be able to show this demo. But usually we cannot use continuation directly in our code. So It's a code base. It's a simple code. I have created a new class over here, which is continuation, and inside I have a few statements. Basically, these are the statement I want to execute by a thread, right? It's a block of code, and over here you see I have written a line which is C1, and it prints the current thread, and there is a line called continuation.yield, and then I have another line over here which is um, uh, another print statement. That's it. So what I'm trying to do over here is, let's say this block, I this is the continuation, and inside there is some statement that I want to execute. So over here I started print statement which is start, and then I call continuation dot run. So all of these are executing inside a thread, right, which is a main thread, because it's I'm running on a main method over here. Okay, so now essentially what I see is, if I will start executing this code, it will create a object of scope, and then it will create object of continuation over here, and then it will print this statement which is start, and then it will start execution this continuation dot run. So when we call this continuation run, we usually end up running this code, right? That's what it's similar to the concept of thread as well. uh, so what it would do is, it will call it will execute this method which is c1, and then immediately it will see continuation.yield. What it would do basically, it will resume, it will suspend it from here, and the executions from line 14, it will immediately come to the line 22, and it will basically execute this line, and then if we call this continuation dot run, the execution will go back to line 16. It will not start again from line number 12. So it will start its execution, or it will resume this execution immediately to the place where it was suspended. So that's what happens with continuation. So if I run this program, I don't know if I can run it. Let me see if I can run it. Sorry, I clicked on debug sudden unintentionally. And if you see the output, it's exactly what it exactly prints what I have just described. It calls the start and then print the C1, and then it suspended this line. Basically, the continuation can suspend itself, and it comes back to the over here, which is next line, and then it comes to the line numbers. Since I call this continuation dot run, it goes again inside this block and it executes this line, and then it comes back to this line. So basically, this is what happens. So now the question gets to be, what benefit I can get from this. Okay. Uh, okay. All right. So benefit of this is basically, let's say I have a thread and I am calling a microservice, which is a blocking operation, right? And to get this result to my current threads, it will take some times. And while I'm not waiting for this, result to get to me as a thread, I'm just blocked. I'm waiting. It's a case of traditional thread. But if we run this same code in a virtual thread, what it do is, since I called a blocking operation, I need to wait for a certain period of time. What I would do, I would suspend myself. I'll move away from my current executions through this continuation things, right? And this virtual thread basically run on top a traditional classical or platform threads, right? So see, the platform thread was executing a virtual thread, and this virtual thread is calling a blocking operation, and I see that I will block this current thread. Rather blocking this current thread, I will suspend myself. I will move away from the picture, and the platform that's executing this current virtual thread is free again. Now it can do other things, like it can execute other virtual threads. So that way, the platform thread, this most uh, uh, the limited number of that we have is not being wasted anymore. It's always working on something else. If virtual thread gets blocked, it will move away, it will remove from the picture, some other virtual thread will come to this picture and it will execute. If it sees another blocking operation, it will just suspend itself, and when the result is available, it will then resume back. And so that's how it works. So if I give in a summary, the idea is mm, you know I have a fork join pool, and in this fork join pool, I have a limited number of platform thread. Let's say 10, 20, it doesn't matter. Let's think about 10 threads, and this 10 threads is going to be always busy executing virtual threads. So now I have a million virtual threads. They're occupying the SIP memory, but they are not wasting CPU, because when they're executing, they're, let's say there is some statement of code it's executing, and it says a blocking operation, it will just suspend from that particular platform thread, and this platform thread will basically execute another virtual threads. So that's a huge thing. So that's essentially what virtual thread it does. It's essentially extremely good for blocking kind of operation. And nowadays, since our modern applications, modern web servers do a lot of blocking operation, because we do microservice, we call network operation, we call database, we call a lot of other third-party services. All of them are blocking operation. And since with the virtual threads, we don't have to worry about blocking anymore. Blocking is cheap. We'll be able to, the amount of thread we have, which is we don't have to worry about how many threads we can create anymore, because for example, essentially will use a small number of threads, and they will be always busy executing virtual threads. And so that way we are basically utilizing our whole resource, and our resources are not being wasted. At the same time, since we have huge amount of virtual threads, we can improve our application supports. That's the summary of the whole thing. So that's what it is essentially. All right. So some other language has this similar kind of features, which is coroutine in Kotlin, goroutine in Go, async wait in JavaScript, Python generators, Ruby has a Fiverr, and finally Java has it well. So that's an awesome thing, and I'm really looking forward to be able to use this in our production code, in near future. So I'm very excited about this whole virtual threads. Uh, um, you know, so I think I have got a question over here. The question is, what will be the top use cases of Loom? For some reason, I can imagine Loom plus Spring. Okay, so top use cases would be server applications. I mean, you can use Project Loom using Spring. It's not a problem. In fact, some frameworks are started using Project Loom. For example, if you know Project Nima, Helidon Nima. I can search it for it. Let me see if I can do that. So just give me a second. Helidon Nima. So they are doing experimenting with virtual threads. So if you want to check out, definitely Helidon. You see, Helidon is on virtual thread. Eventually, Spring will come. Spring will eventually will start using virtual threads. So what happens with this Spring nowadays? The traditional server application. What happens is Tomcat. Let's say you are running Spring framework on Tomcat. Tomcat will have a pool, regular thread pool, and the thread pool will have a number of threads. You can definitely customize it, but you can, let's say you have 400 threads, and how many requests you can send doesn't matter. It will use those 400 threads. And since it's a request per thread model, but that means a request is served by one thread. That means your throughput at max can be 400, right? At a certain period of time, because you have only 400 threads. But with the virtual thread, you don't have that problem. You can have a lot of threads, so your throughput will dramatically increase. All this waiting inside the applications are no longer case, because your threads are not waiting. The platform threads are always executing, so you are utilizing your resources. But they'll be waiting, right? You send a request, and the request is a blocking operation. It's waiting for database to get data from database. So there will be a round trip, right? Network latency. While this network latency is being, it's doing this round trip, or it will move away from the picture. Basically, so it will just sit there, and that's it. So that way, we're not just wasting our CPU. I have a excellent, um, um, I have an excellent, I would say, analogy for it. So let me talk about this analogy. How virtual thread basically works. So let's say, think about a bank with a fixed number of teller. Teller means over here you can see teller is a thread, like platform threads. So idea is generally it would take time to process each customer, say an average of 5 minutes, right? You go to the bank and you ask something, and you do something with bank teller, right? So it takes some time. But while you are basically you are being served, the teller needs to do certain things. For example, he needs to call some other person, or he needs to wait for some information from email. So while this information is not available to this teller, he is stuck with you, right? You are both are waiting in same positions. So while you are both are waiting, work is basically done. Basically, you both are just waiting idle in front of them, each other. On the other hand, with the virtual thread, what it would happen is teller, you go to the teller, you just ask him to do some things, and he needs to wait for an information. What he would ask you to do is, here's the pants, you know, uh, wait there, sit there, idle. You are a virtual thread. You are just on a memory. You are not wasting the CPU cycle. uh, when your information is available, I'll pick you, or you will come here again. While your information are not being available, I'll work with another client or another customer. So basically, teller is always is busy with serving other customer. If you need to wait, you'll just wait outside, sitting on the bench. So the whole process is not disturbed, and no teller is basically waiting, and they're always working. So that way, you are optimizing your workforce. You are getting more throughputs, because that way you will be able to serve more customers. So throughput basically serving more customers, right? So that's the idea of virtual threads. I hope you understood, you got the answers. Let me know if you have more questions. All right. So yeah, so there are many benefits of having virtual threads. For example, a tip: request per thread style server programming. It become easy now. No longer required to be reactive mind bending programming. I mean, there is alternative. We had reactive programming, right? But the reactive programming has certain limitations. I would say it become easily complicated. There is a learning curve. The debugging become difficult. All those things. But with this traditional imperative way of doing, programming is now available again with this virtual thread. You can create millions of them, and blocking is totally cheap. And the difference between virtual thread and as a programmer, I don't see any difference between virtual thread and per platform thread programmatically. I would say there is differences, definitely. The way we are on a deal, for example, thread local, synchronization block, all those things are same as traditional threads and virtual threads. So if we want to debug, we'll be able to debug virtual thread easily, right? So those are the benefits. And we no longer have to maintain thread pool. The concept of thread pool are abolished using the virtual threads. All right. There's some limitations as well. For example, let me see if I can show you some limitations. It's still being worked on, so it's um, you know mm, it's still being worked on. So a lot of things will improve as its days goes, right? Hopefully. So let me see if there is another comment over here. Concurrent code has always been a beta of work with. Do you think Loom will become mainstream after 20, or will it become very useful to? So I mean, concurrency is a concurrency or Java threading model is from day zero, right? Well, Java is like 27 years old. So as a regular programmer or day two programming, we don't always deal with a lot of concurrent things, right? Sometimes we need to do, but we always end up using concurrency all the time because it's a Java and Java is built of concurrency. Even though if we don't need to directly work on concurrency, for example, we don't always create threads. For example, you are given an example of a Spring. As a Spring developer, uh, our typical code is basically you declare an endpoint, you call a service, and you communicate with the database, and that's it. All these things, internal things, are taken care of the Spring frameworks, right? And the Spring frameworks definitely use a concurrency model. Uh, and so your life would be when virtual threads is available, the JDK Spring framework definitely is going to use heavily the virtual thread. You're probably not going to use them directly. If you want to, you can. You definitely can use virtual thread directly. It will be easier. And if you want to, basically, when you write a blocking code nowadays, it's a problem, right? You have to think through. Am I blocking this current thread and all those things? Now you don't have to think about it. You can block without thinking, so that's a less pain for you. I have an example over here. So there is an example. I can give you an example over here. um, so probably this is not the right example. Anyway, never mind. The idea is, let's say you need to download 10,000 emails from a you are writing a method that will download 10,000 emails, and using traditional thread model, either you have to write a for loop. Let's say you are writing a for loop to download all these 10,000 emails, then it will become serial, right? One, it will download first image, and then the next image, then next image. It will take a lot of time. If you want to parallelize these things, you have to do a lot of works, and you have to chunk it. You have to create a lot of threads. So you have to do a lot of experiment around it. But with virtual thread, you don't have to worry a lot. You will typically do a for loop, and each request you will do under a virtual threads, and that's it. You will get a better performance on top of all of this, and you don't have to worry a lot. So I would say your life is going to become more easier, more easy compared to earlier, process. And a lot of people use, nowadays, a lot of people use reactive framework, which is great. I don't deny that, but it has also challenges. With virtual threads, you don't have those challenges. Pretty much, how thread works traditionally. You are just going to use the virtual thread now, and it will remove some of your burden. That's how I see it. And since virtual thread has still some limitations which are being worked on, hopefully some of them will be solved when it's available with the JDK. So all right. So that's pretty much all I had. There are some resources available over here if you want to look at it. For example, definitely the wiki, which is you can download Project Looms. There are a lot of articles over there. You can certainly read all of those things. And virtual is under JEP, which is 425. There is a lot of information you can consume. And there is a presentation on by Ron Pressler. He's the guy who's the lead of this whole project. So if you want to listen his podcast, then you will get more information from him, hopefully. And there is a documentation over here about Project Looms and some a few other guys, Adam, Haynes, Kay. They also give a presentation on virtual threads. You can watch their content as well to get to know more about virtual threads. But yeah, it's a new big thing. It's going to dramatically reduce it's going to be dramatically change the landscape of Java concurrency for sure. That's pretty much given. And yeah, so thank you. That's all I had for this session. And if you want to reach out to me, feel free to reach out to me through this Twitter. I'm very active on Twitter, and nowadays I'm trying to go into Mastodon, but Twitter is still the most 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 of the time I use Twitter. Basically, that's what I wanted to say. Um, so follow me on Twitter. If you have more questions, just send them to me. I'll definitely try to help as much as I can. Yeah, that's all I had. um, Let me know if you have more questions. So I'm trying to find my window where the
Yeah, thank you, Bazlur. I will remove the presentation, and well, giving you all the thanks for the talk. It was very good. Also the questions, and thank you so much. And whenever you can join us here, hopefully in the future, and you're very
yes,
welcome.
I'm really looking forward to maybe some in future I'll be able to be in person on your events, and I'll tour around your city, and that will be amazing. Thank you very much for having
Thank
me.
you. Thank you so much. Well, I'll be in the broadcast. Thank you. See you.
uh, all right, take care.